Welcome back, students. It's Miss Hernandez. Today we're covering section 7.10, ternary ionic compounds, naming and formula writing. Okay, so remember, everything that you see here is from your packet on CK12, just like you see here on the electronic version of it. All right, let's get started. How many varieties of pizza can you think of? There's a lot of toppings that you can put on pizzas nowadays, right? So the varieties, if you were trying to create combinations, there are a number of different combinations of toppings for pizzas nowadays, right? There's probably thousands of them, maybe even hundreds of thousands. Who's going to help me read?
Most people enjoy eating pizza when they order a pizza either by phone, online, or in a restaurant. They don't just order pizza. Even the simplest binary pizza will have a topping and cheese, maybe pepperoni, maybe something else. However, many pizzas quickly become more complex. One person may want pepperoni and sausage. Another may wish to order Canadian bacon and pineapple, and then you have the folks that can decide, so they order half this and half that. The combinations may be more complex, but the same basic ideas about pizza are valid.
Definitely. Thank you so much, Alexia, with that reading. So the whole introduction is about, easy to make pizzas and then the more complex orders of pizzas, right? Back when I was, young, living with my parents and my brothers, me and my brother we always fought about what we wanted on our pizza. And it always came down to the fact that he wanted mushroom, I wanted pepperoni. So my parents, of course, they wanted their supreme pizza, so we always just ordered two. So instead of ordering an extra pizza, what my parents would always say, well, just put half and half. And then the other one is their version, right? The supreme. Because we can't mess with theirs, right? Nowadays, me and my husband, well, I'm a very simple person. If I'm going to Peter Piper, hook me up with that pepperoni and bacon, and I'm satisfied. If I'm at Pizza Hut, I prefer pepperoni with beef. Okay. But if my husband's doing the ordering, oh, you better believe that he's going to be ordering that meat lovers or veggie lovers pizza. Okay. So when the guy, as they're preparing the pizzas, it's very easy for them to complete mine. But on the other hand, it's going to take a little bit more time for that guy to prepare my husband's version, right? Meat lovers has a lot of everything, right? A little bit of everything. And the same thing goes for veggie pizzas. All right. So the reason why it's coming up, when you are naming and formula writing, you have the easy version, which we covered on Monday and Tuesday, binary ionic compounds, right? We always had your cation, you always had your anion. Those were elements, right? It was very, very easy. You had one element as your cation, you had one element as your anion, and then you applied the rules, just as we described them earlier in the week. Now, today we're talking about little more complex, larger compounds where you will probably have one of those polyatomic ions that we were talking about yesterday, right? And I always like to call them polys. So you'll hear me say, instead of polyatomic ions, I just call them polys to make it quicker. All right, let's get started. Ternary ionic compounds. Not all ionic compounds are composed of monatomic ions, right? Like you have in binary, right? Binary are all about monatomic ions. You got elements for each, for your cation and for anion. That's known as a monatomic ion, just one ion or one element. For ternary, a ternary compound is an ionic compound composed of three or more elements. Okay? For ternary ionic compounds, you got polys in there, and polys have a tendency to always be more than one element. So if you already have a poly in there with two elements and it's connected to another to another cation or anion, well, you're going to have at least three elements, right? So in order for you to apply the rules for ternary compounds, you must have three elements or more. And let's look at the example. If you look at the example that they have given us here, you can see that calcium is one element in purple, phosphorus is another element in blue, and oxygen is your third element in like a fuchsia color, a lighter version of purple. How do I know that they're all each elements? Well, each of them has one capital letter, right? Each capital letter indicates one element from your periodic table. So here you got 1, 2, 3 capital letters. There's at least 3 different elements in this compound. It's considered a ternary compound. Can you have more than 3? Definitely. If you have less than 3, that changes into binary compounds. All right. In a typical ternary ionic compound, there is still one type of cation, one type of anion. The cation, the anion, or both can be a polyatomic ion. Okay. In this case, calcium is a cation, but it's not a poly. PO4 phosphate is a poly. Okay. And how do you know it's a poly? Well, all you got to do is you go to your reference material, which in this case is our ion sheet. You look at the second column on the bottom half of the page, and this is your list of polyatomic ions. Okay, if what you're looking at, if the cation that you're looking at does not come out on this list, more than likely it's an element. Okay, more than likely it's an element. All right, your turn. I want you to tell me or to identify the ternary ionic compounds from the list below. Which one is considered ternary compounds? Oscar, Alexia, come on, write it in. Type it in. Type it in. You can use either the Google Meet chat or you can use Pear Deck. Let me know which ones do you think, Mario, you too. Which one do you think are ternary? Which of these compounds has more than three or more elements? All right, so Oscar's already pointing something out. He's saying letter G or letter B. There's more than one answer. Okay, there's more than one answer for this one. So it can actually be both. Okay, let's check it out. So let's go and let's talk about letter G at the bottom of the page. Letter G has one capital letter, two capital letters, 3, 4. That is definitely ternary, right? Ag, silver. C, carbon. H, hydrogen. And O, oxygen. Good job, sir. All right. The next one he said was letter B as in boy. So we got 1, 2, 3 capital letters. That's 3 elements. Definitely ternary, Oscar. Good job. What elements do we have? Iron, nitrogen, oxygen. Okay. Mario, he is saying letter G and letter A. Okay, well, we already talked about G. Let's go to letter A. How many capital letters? N-A, right? N is capitalized, S is capitalized, O is capitalized. That's ternary. That's definitely part of our list. You got sodium, you got sulfur, and you got oxygen. Great job, Mario. Alexia, letter C. Okay, let's look at this, Alexia. Be careful with these letters, okay? I see capital letter A and capital letter C. If you look at the third letter or the fourth letter, I, it looks like an I. It's not an I. It's L. It's L. Okay, both of these are L. How do I know that it's an L? Let's look at our poly. Is there a poly that has the capital letter C and the capital letter I? And we're just going to verify that, okay? So if you look at your poly list right here, oops. On the right side of the page, is there a poly with CI? CI, 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 CI. No, that is an element. Be careful with that, okay? I've been telling you since the beginning of the year, these L's and these I's, they look very, very similar. Be careful. It will get confusing. Even if you looked up AI, that is not a poly either. All right, so letter C is out. What about letter D? Is that N? Is that yes, it's a ternary? Or no, it's not ternary, it's binary? What do you think about letter D? Binary or ternary? What would you say about letter D? Remember, it's definitely binary. 2 capital letters, 2 elements. Oh my God, I can't stop coughing. I wish I had a cough drop right now. Okay. Did we talk about letter E? Is letter E a ternary compound? Is letter E ternary compound? Or is it binary? What do you think? Binary or ternary? I need to know. Be specific. Let's use our vocabulary. Ternary. Why is it ternary? How many do you see, Oscar? How many elements? Okay, what's the first one? N. What element is N? Nitrogen, right? H. What's H? Hydrogen. What's P? Phosphorus. And what's O? Oxygen, right? You got 4 different elements. Letter F, ternary or binary? F as in Frank, ternary, binary. 3 capital letters for ternary, binary, 2 capital letters. What do you think for letter F? Is it ternary, 3 elements, or is it binary, 2 elements? Definitely binary. Okay, great job, guys. Different compounds, different rules. All right, let's talk about naming, the rules for naming ternary ionic compounds. So this first section is all about naming. We're going to take it slow. The process of naming ternary ionic compounds is the same as naming binary ionic compounds. The cation is named first, followed by the anion. And let's do an example. I'm going to go to Jamboard. If we go to Jamboard, and I give you the example of NaCl. 2 capital letters, 2 elements. Let's name the cation. Let's name the anion. And let's see if you can remember what we're supposed to be doing. Okay? What's the name of Na according to the periodic table? Na. Anybody see it? Na. I know it's in the top version here. but I'm really bad at finding these symbols sometimes. PTNiCO. Where's Na, guys? I know it's over here. Right? Oh, isn't that it right there? What's it called? What's Na called? Sodium. Okay. Do we change the name of the cation? Do we change the name of this guy? Yay or nay? Does the cation's name change when we're doing binary naming? That's a big no. Remember that. No, you do not change the first one. Okay, what's the name of this guy? Cl. Let's go to our sheet. Usually your non-metals are over here. Chlorine, right? Originally it's chlorine, and Oscar's already giving us the correct last name, or the correct part, the second part. This is what you see on your periodic table, chlorine. According to the rules for naming binary, you always cross out the ending and you add IDE, which is exactly what Oscar did without even having to be told. Very good, sir. Chloride. That is naming of binary. The first element does not change. The second element, and I say element, if your anion is an element, you still have to go back to binary rules, take off the end, and add that IDE to the end. Okay? Remember that when we're doing this next part, when we discuss it, okay? Everybody clear? Hey, Irvin, you didn't even say hi. You just came in. Usually you give me a hello, miss, I'm here. Okay. Some examples are shown in the table below. Examples of ternary ionic compounds. So right now, they're already giving the formula. They're already giving you the name. I'm just going to work with the formulas, and we're going to make sure that these names are correct. And I'm going to show you how to do it. Okay? If I don't show you, you're going to just get yourself confused when you do it on your own. And you will be doing it on your own. So the first one, NaNO3. Let's do that one first. NaNO3. So the thing about polys is that most of the time, most of those polyatomics, they are usually nonmetals. Okay, so if you run into the beginning of a compound and it starts with a metal, more than likely it's not a poly. Okay, there's only a couple of metals that are involved in those polyatomic ions, and I can show you right now. If you look at the list, oops, wrong one. If you look at the valence list right here of the polys, you'll notice nitrogen, carbon, chlorine, hydrogen, oxygen, carbon, nitrogen. Ooh, here's your first metal, manganese, Mn. Here's your second metal, chromium. Here's your third metal, chromium again. And then it goes back to carbon, oxygen, sulfur, phosphorus, and then arsenic. Okay, and I think arsenic is a non-metal, if I remember correctly. Now I'm doubting myself. I'm pretty sure it's a non-metal. No. Let me just double check it just for my sanity. Yeah, it's a non-metal. Okay, it's right here. Element 33. Arsenic. Okay, so it's not a non-metal. The only ones that you will usually see as metals are that manganese and chromium. Everything else on this list starts with a non-metal. All right. So if we go back here to the example they gave us, Na is not one of those metals that we mentioned. It's not manganese and it's not chromium. So you got to assume that it's just the element by itself. And we already know what the name of Na was because it was part of our first example, our review of binary. We know that Na, what's the name of Na, guys? Sodium, right? So I'm just going to write sodium. Excellent. Okay, so that probably means if your cation is not a poly, more than likely it's your anion that's the poly. In this case, NO3. If you look up NO3 on your list for polys, which is what we have here, what's the name of NO3? Anybody see it? Na, no, not that one, not that one, not that one. Here. Isn't this it? NO3? Correct. Now, the thing about polys, if you run into a poly as a cation or an anion, DNC it. DNC means do not change it. Do not change. Whatever you see on the list, that is what you write. So what's the name of this compound? Sodium nitrate. And if you go back to the PowerPoint, to the Pear Deck, that's exactly what they have here. Sodium nitrate. Any questions on the first example? Your second example, NH4Cl. NH4Cl. So let's look at the first element, nitrogen. It's not a metal. More than likely, it's a poly. So we're not going to we're going to look for N, and we're going to see if there is an H and a 4 attached to it. And we're going to see if there's a name for it. So valence sheet. Here, you're looking at for N's, not NO, but NH. What's it called? Here it is at the top of the page. Ammonium. It's a poly. DNC, do not change. DNC, do not change your poly. Do not change polys. So if it's called ammonium, you better write ammonium. Okay? But what do you know about this guy? Cl. It's not a poly. We established that earlier. There is no element, there is no poly that has a Cl by itself. So we're going to go to our list of elements. We got chlorine again. What did we do to chlorine in the review for the binary? Did we DNC, not change it, or did we change it in a way? No, DNC is only for who? Polys. So if it's a negative, it's an anion. What do we do to anions? What do we do to anions? What do we do to NaCl? When we did NaCl, Oscar, you told me earlier, wasn't it sodium chlorine? Was it sodium chlorine? Is that the answer you gave me earlier? Sodium chlorine. That was the correct name that you wrote earlier. I'm looking at it right now, and you told me that look at the time. Chloride. Very good. Drop the ending and add that IDE. Remember, if your negative charge is an element, you have to add IDE. The last one, iron, FeOH3. Fe parentheses OH, close the parentheses, 3. Okay. What's the name of Fe? What's the name of OH? Fe is not one of those metals that's part of the poly list. It was only chromium and manganese. Cr and Mn. Iron, Fe, is not part of it. If you look up Fe right here, you have iron, right? It's known as iron. So I'm going to write iron. Okay, this guy, iron. What about this guy? He's a poly. He is a poly. What's the name of this poly? It's a polyatomic. It's not an element. It's going to be here. Oscar, look for it. What's the name of OH? I got NH, NH. I'm looking for OH, 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 OH. There it is. OH is hydroxide. It's a poly, DNC, right? This guy's a poly. Don't forget, DNC, do not change. Hydroxide. Okay? Now, we're going to have to do some extra work, and I'm going to tell you why. I don't know if you look at your valence sheet. Look at iron. How many brothers does iron have? How many brothers are there of iron? How many charges do you see? 2. So you need to make sure that you identify which one you need to identify which ones you're working with, okay? So you're going to have to do some extra work, okay? You're going to have to undo this formula, right? Undo it, meaning uncross the charges. If there's no number for that element, always assume it's a 1. So technically, this is what was written before, right? Before they created this formula, this is what you saw. Now, I need you to verify, is OH, according to our list, -1? OH, right here. Do you see a -1 here? Hold on, I need to send a text to my mom real quick. Something came up. Okay, so if you see a -1, that means the charge is correct for the second one. The charge is correct for the first one. So the Roman number, or which one we're working with, is iron, Roman number 3. So that only happens for metals that have more than one charge. And you can see that most of them, they don't have more than one charge. Most of them only have one charge. So you don't have to do what we just did most of the time. It should only come up every now and then. Okay? Most of the time, all you got to do is what we did here in slide number 1, or example number 1 and example number 2. Okay? When one or more polyatomic ion is present in a compound, the formula of the ion is placed in parentheses with a subscript outside of the parentheses that indicates how many of those ions are in the compound. In the last example, there is one Fe plus 3 cation and 3 OH anions. All right, this is where we're going to spend the rest of the period on. Examples where you will be trying to name these guys. Oscar, you got the hardest one. You're doing number 3. Mario, you got the easy one, number 1. Number 2, Yalexia. And number 4, I want Irvin or Arlette to try it. The rest of you guys, just watch. And if you can, practice with us. Okay? Practice with us. It will not hurt you. Okay? I prefer everybody try at least one. I would like the rest of you guys to try number 1 along with Mario. Okay? Mario, don't worry. Mario, I'm going to help you with yours. Okay? So right now, we're going to be looking up LiNO3. Okay? LiNO3. Oh, no, I don't want that color. All right. LiNO3. Mario, be ready. I'm going to be talking to you and asking you questions, okay? So right now, we're looking for the element Li. Why? Because the only two elements, the only two metals that are part of the poly list is Cr and Mn, right? Manganese and chromium. That's not this guy. This guy, his name is lithium, okay? So we're going to write lithium, okay? And we can prove it. If we go to the valence sheet,
it's lithium nitrate.
We need to explain it, though. I'm still asking you questions. So Li, his name is lithium. Okay, that's great. Okay, so we wrote lithium. I agree with you, Mario.
And is nitrogen.
Yes, but now I'm looking for a poly known as NO3. So I'm going to go to our reference material because when you go into class, when we go back live, you need to be able to do this. Okay, so let's look at your poly list, sir. And you're looking here in the middle column. You're looking for NO3. Tell me, top, bottom, or in the middle, where is NO3? Where is it, Mario? Is it towards the top?
Middle.
In the middle? Let's see. Right here. There it is. Very good. NO3 is nitrate. So is that what he writes? Yes, he does. And that's what he did. At least I hope he did. And he did not use the internet to get the answer. Anybody can do that. It's called lithium nitrate. Okay? All right, next one. Let me go erase this one. Okay. Yalexia. MgOH2. MgOH2. G is magnesium. Very good. We don't change the name. And you can look it up, right? Magnesium is right here. Mg. So now we're going to be looking for this OH, right? This OH on our valence sheet, it's oxygen and hydrogen, correct? But it's a poly. OH, look for it, Alexia. Where is it on this list right here on the right side? Where do you see OH? If I start here, do I keep going? Tell me when to stop. Nombre, Alexia, ya llegué al bajo.
Donde dice el, ay, pero todos dicen negative one. Ahí donde dice Hydroxide on the same.
Yes, ma'am. Look at that. Excellent. There's the OH. What's it called? Hydroxide. Very good, Alexia. And that's all she writes. Hydroxide. Because that's the name. And I don't have to worry about that extra work that we did here, right? Because both lithium and magnesium have only one charge. Look at that. Magnesium, it only has a +2 charge, right? Lithium only has a +1 charge. I don't have to do the extra work that Oscar's going to be doing, or at least that he should be doing. Okay? All right, Oscar, did you come up with the name before I help you? Were you able to figure it out? Iron sulfate. But didn't you have to do that extra work that we did in the last example? Yes. What Roman number did you get? Did you get to figure it out, or do you need some extra help? There's nothing wrong with asking for help. Nothing wrong. Okay, I got you. I got you. So Fe2SO4 3. Okay, so let me change the color. Fe2SO4 with a 3 on the outside. He already did the hard part. He already identified the metal. He already identified the poly. He said that Fe is iron. He said that the poly is named sulfate. Right? Perfect. Great. That's great. That's excellent job. All right. So if we go here to the valence sheet, we can tell that iron has more than one charge. You can see it at the very bottom right here. Here, let me point it out to you a little better. Right here. This one. Here, Fe, right? You can see it right there. It's got more than one charge. It's going to require some extra work. It's going to require for us to uncross. All right. Brooklyn, hold on, Brooklyn. Okay, so then that means Fe, what number crossed? What number uncrossed? 3. 3. SO4, what number uncrossed? What number uncrossed? What number moved up this way? What number, guys? What number goes this? Sorry, say it again.
2.
Very good, ma'am. 2. So the only thing that's left to do is to verify that this charge is correct. So we're going to go to the sheet, the valence. SO4. SO4, right here. It's a -2. So if this guy is a -2, that means this is correct. And what Roman number should Oscar be writing in between his name? 3. So what's the full name of this guy? Iron, Roman number 3 in parentheses, sulfate. Okay? Iron 3 sulfate. Done. Okay? The last one, I don't think we have time to do it. We'll finish it tomorrow before we move on to writing formulas and watching the video. Okay? Have a wonderful day. Stay wonderful. Be careful. And I'll see you tomorrow.
Bye, miss.
Bye-bye.